Good afternoon, everyone. Thanks for staying all the way to the end. It's amazing of you guys. Hope you guys have a wonderful day so far. We are going to talk about deploy recording server using Kubernetes. Before we start, just going to talk a little bit about myself and the company. My name is Lei Wang. I work at Wishlife. Our technology stack is we use React and React Native in the front end, and we use GraphQL for the API, and we use Clojure for the backend development. We use video a lot because Wishlife is we use video to help family protect their legacy by interviewing the family and also providing the communication tools for family and recording the communication and also record the interview, everything for the future generations. So our kind of core business is around the video, and also we believe the video of the family really can protect the future generation. It's a very valuable part. So before we use Agora, we use something called Flash and Wowza. I think because we have started from 2013, so by the time the Flash is probably the only viable solution on the browser. I'm going to talk a little bit about, this is our old recording flow. As you can see here, before our Flash client get an authentication from the application server, and then streaming to the Wowza media server. And the Wowza media server will do the recording as well. There's a problem with this flow. First, it's really hard to maintain the media server to keep up to date and to patch the security, security issue, everything. That was really hard to do that. And the second part is hard to scale because our media server, so there are two problems here. First one is the streaming. The second part is recording. For the streaming, it's really hard to scale because, as everybody knows, to get a better kind of performance on the streaming, you have to place your streaming server as close as possible to your client. And then, but that is kind of really hard to do in a global scale. So that problem. As a kind of application developer, we don't really have it's not in our value proposition to do that. So the third problem is very costly because if we want to achieve good user experience, we have to place a lot of media streaming server all over the places. So the media server costs a lot of money on license and hosting, and also bandwidth as well. The fourth part is Flash recording. We had it a few years ago. Like everybody knows today, like Flash is dead. And then WebRTC is the way to go. So that's kind of that's what triggers us to move over to the new kind of flow. In the new flow, before we can only support streaming on the web browser. Right now with the WebRTC, we can stream in from web browser and also from the mobile devices. And even better, those web browser client can talk directly to the mobile client user, so there's no difference. And then, so in this kind of new flow, because we using Agora WebRTC SDK, so actually Agora is taking care of the streaming for us. And then leave us only to handle the problem of the recording. And also, I believe Agora also handle recording as well. But we started this project about a year and a half ago. By the time there was no such solution. So we built our own kind of recording solution by ourselves. And also there are some other concerns it's better to have a recording by ourselves. So for us, then the only problem we need to deal with is right now it's in the recording. So for recording, we don't need to handle, the scaling of the recording is so much easier comparing to streaming because recording is mainly backend work. We don't need to play, we can just play in the server to as close as the media server as close to Agora, and that would be good enough. We don't need to worry about where the user is coming from. We don't need to, that's a lot of, it's a huge problem has been solved by now. So with this new flow, right now, we only need to be responsible for recording, and it's very easy to maintain on the scale, and it's paid by usage, which is even better. I don't need to pay a lot of streaming server license, everything. And the WebRTC client support is so much better than the Flash. We actually, I don't know if anyone sit here ever work on a Flash before. It's very painful to work with the Flash on the browser. And also we get something for free, like before we handle the streaming by ourselves. It's a hard problem for us to say to allow multiple users to communicate through video online, even better across multiple platforms, which is getting this kind of benefits pretty much for free. So back to the application, since Agora is taking care of the streaming, so for us, we only need to handle the recording part. So to integrate the recording with Agora, because we are using Clojure as a backend programming language, Agora doesn't provide that kind of API. So we wrap the Agora Java SDK as a Clojure library. So all of our backend can just use the Clojure library to directly do the recording, everything. So end up we package our application as a jar file, and then we just deploy the jar file combined with the Agora Java SDK and then Agora C++ SDK into the container. So that's how we started the deployment. So right now we have an application, everything packaged well. So we need to think about how do we deploy everything to the production environment. Before Agora, we have to deploy the streaming server, the individual streaming server, which is kind of hard to do. So, but at the time when we think about the new deployment strategy, we figure out it's better because right now we don't need to handle the streaming part. To deploy the recording, it's so much easier to just deploy recording using Kubernetes because right now it's just a matter of just a matter of the workload needs to be deployed, and there's not too much of front end. The front end communication only a few kind of API call from the server side. Those kind of recording servers pretty much just running as a backend job. It's so much easier to maintain that way. There's no direct communication between the recording server to the front end. So we package everything, like we said, we have our recording server as a jar file, and we package everything into a Docker image. And with that, it's pretty much get rid of all the maintenance work we had before to really to update a server or anything. Every single time we need to update our deployment, we just need to update in this Docker image and rerun the deployment script. That's the only thing we need to do. So for recording, there's some special things needs taken care because for recording, it's not a stateless application. It has a state because the data has been recorded, needs to be saved in the server, and it has to be safe. And also, this data needs to be able to, in the production environment, if our server crash, and then some recording is happening in the middle. So we need to be able to retrieve those kind of data. So that's so in Kubernetes, the path we took to get into the stages. At the very beginning, we just deploy those kind of recording server without worrying about the persistent storage. We just accept the failure. Sometimes the server might crash. Okay, we might lose the recording. That's easy. We just go through that way. So this is a very simple way to deploy an application. So basically, in Kubernetes, we have an ingress, which is will be an endpoint to the client side, and it will take a client request, and then the ingress will then send the request to the service, and the service will distribute the request part. Part is actually where those kind of recording server runs. So we deploy this one, but the thing is there's no persistent storage. So if a part dies, and then all the data while we're doing the recording, everything will be gone. So we introduced the storage to this kind of to back the part. So if the part dies, but the storage, all the data has been recorded, will be saved in storage. If the part dies, and the new part will replace the old part, and then will pick up anything left over on the storage. So there's no data will be lost. So this is the second way. Everything works good, but once you get into the point where you have too many of recordings, like 50 recordings or 100 recordings, one single server wouldn't be able to hold the node. So you need to distribute those recordings to multiple environments. So that's how we get into another type of deployment. So we want to have multiple pods to be able to hold those kind of recordings. So we use the stateful set as our persistent storage. So pretty much in Kubernetes, there's a way you just define, okay, I need define a set of stateful storage, and then you just gave a number of storage, and then the stateful set will help you to maintain a fixed number of parts, and then each part will be mapped to a storage. So all those kind of storage will be able to hold all those kind of recordings you had before. And then whenever this part has been replaced or has been restarted, and the storage will be I'll keep all the data for you. So that's the kind of a deployment kind of the way of deployment. I'm going to show some demo over here. So in this deployment, I have a one part which is running right now, and then this is the ingress. This is the IP address. So that user will hit this IP address, and then they will get hit in the service, and the service will distribute the request to all the parts. And then, so let's start now. Oops. Oh, sorry. Okay. So let's start some recording. Okay, we started client-side recording, and we have to send a request to server-side. It says start recording, and then we stop here. Let's check how the backend is. Hopefully we can see some new recording from here soon. Oops. Okay, the record has been done, so we just wait for the post-processing to be. So if, okay, while it's doing the thing, let's take a look at the other thing. Say if right now we have one recording service running, what if we want to change to 3 or 4 recording servers? And then we just change it to 4, and then restart the service. and it will start a full recording server for us. We're going to take a look. So right now there's no resources. Okay, as you can see, there's one is creating right now. And we are actually design, as you can see, we want a full recording server to be started. And right now there are two has been started. So as you can see, there's one is running already. And then there's another one is in the creating phase. So we have two servers running right now. And we can take a look at the log of the first one. And then we can also take a look at the log of the second one. You can see the first one has been started. So as you can see, right now all 4 servers has been started at this moment. So just synchronize like that, like the whole deployment is so much easier to deploy something to the server. Like before, if we need to bring up any new recording server, it will be so much more complex. Even you use any automation like Ansible or anything, you still need to deal with a physical server. This way is so much easier. You just change one number. And then all this deployment will be done automatically. And if you need to upgrade your recording server, anything, you just update your Docker image, and then apply the deployment again. It will automatically, it can do the rolling update. You can have a low downtime rolling update on all your backend server as well. So this, let me check out one more time on the recording to see whether we got any recording. Yeah, we got a recording. We can play back. It's a little bit slow because it's running through my phone. So, but hopefully it can come up. Yeah, that's the recording we just did. Yeah, that's it. Thank you, everyone.